Utilities and authorities having jurisdiction, AHJs, typically mandate service upgrades under the following circumstances. Firstly, safety hazards. Exposed wiring, overloaded circuits, or faulty grounding can pose significant safety risks and must be addressed promptly. Knob and tube wiring is an outdated and potentially hazardous method of wiring, as it lacks a grounded conductor and can suffer from insulation degradation over time. Secondly, code compliance. Electrical codes evolve regularly to address safety concerns and technological advancements. Older homes may not meet current code requirements, necessitating upgrades to ensure compliance. Thirdly, increased electrical demand. Modern appliances and technology consume significantly more electricity than those used in the past. An outdated electrical system may not be able to handle the increased load, leading to potential fire hazards or service interruptions. Grandfathering refers to the practice of allowing existing electrical installations to remain unchanged even if they do not meet current code requirements. However, this is typically granted on a case-by-case basis and does not exempt the installation from safety concerns. In the case of an old home, the following upgrades would be recommended. 1. Service upgrading. Increase the voltage to 220 volts and install a grounded service panel with separate circuits for appliances and lighting. 2. Grounding installation. Add a grounding system to the home to ensure proper fault protection. 3. Wiring replacement. Replace the knob and tube wiring with modern wiring methods that meet current code requirements. 4. Circuit breaker panel. Install a modern circuit breaker panel with the appropriate amperage rating to handle the electrical load. 5. Safety devices. Update outlets, switches, and other electrical components to meet current safety standards. By addressing these concerns, the utility and AHJ can ensure the safety of the home's occupants and prevent potential electrical hazards. To elaborate on safety hazards, consider scenarios where insulation on older wiring has deteriorated. This can lead to shorts and arcing, significantly increasing the risk of electrical fires. Exposed wiring presents a direct contact hazard, potentially causing severe electrical shock or electrocution. Overloaded circuits, often a result of increased demand on outdated systems, can overheat and ignite nearby materials. Grounding issues prevent the proper dissipation of fault currents, increasing the risk of shock and damage to appliances. When it comes to code compliance, the National Electrical Code, or NEC, is regularly updated to incorporate new safety standards and best practices. Older homes may not have features like arc fault circuit interrupters (AHJs) or ground fault circuit interrupters (GFCIs), which are now standard requirements in many areas to prevent electrical fires and shocks. Compliance with current codes ensures a safer electrical environment and reduces the risk of liability. Modern appliances place a significant strain on older electrical systems. Items like air conditioners, refrigerators, and electric heaters draw considerable power, potentially overloading circuits designed for much lower demands. This can lead to frequent tripping of breakers, flickering lights, and, in severe cases, electrical fires. Upgrading the service to handle modern loads is crucial for safety and reliability. Grandfathering is not a blanket exemption from safety regulations. While it may allow certain existing installations to remain, it does not absolve homeowners or utilities from addressing safety concerns. If an existing system poses a clear and present danger, even if it was originally installed to code, upgrades may be mandated. Regarding service upgrades, increasing the voltage and amperage of the service allows the home to handle modern electrical demands without overloading the system. Installing a grounded service panel provides a central point for distributing electricity safely and efficiently throughout the home. Dedicated circuits for appliances and lighting prevent overloading and reduce the risk of fire. Proper grounding is essential for electrical safety. A grounding system provides a path for fault currents to flow back to the source, tripping a breaker or fuse and preventing electrical shock. Without proper grounding, a fault can energize metal parts of appliances or the electrical system, creating a significant shock hazard. Replacing knob and tube wiring is often necessary to improve safety and reliability. Knob and tube wiring lacks a grounded conductor and is prone to insulation degradation. Modern wiring methods, such as non-metallic sheath cable and M cable, provide better insulation, a grounding conductor, and increased capacity. Modern circuit breaker panels offer several advantages over older fuse panels. Circuit breakers are more reliable and provide better overcurrent protection. They are also easier to reset and do not require replacement like fuses. A circuit breaker panel with the appropriate amperage rating ensures that the electrical system can handle the load without overloading. Updating outlets, switches, and other electrical components to meet current safety standards is essential for preventing electrical hazards. Tamper-resistant receptacles, TRRs, are designed to prevent children from inserting objects into the slots, reducing the risk of electrical shock. Arc fault circuit interrupters, FSIs, protect against electrical fires caused by arcing faults. Ground fault circuit interrupters, GFCIs, protect against electrical shock in wet locations. Utilities and AHJ play a critical role in ensuring electrical safety. By mandating service upgrades when necessary, they can prevent potential hazards and protect the public. Homeowners should be aware of the risks associated with outdated electrical systems and take proactive steps to upgrade their systems when needed. A qualified electrician can assess the condition of the electrical system and recommend appropriate upgrades. In summary, when considering service upgrades, the first point is safety. Prioritize addressing any immediate safety hazards such as exposed wiring, damaged insulation, or overloaded circuits. These pose immediate risks and should be rectified without delay. Next is code compliance. Familiarize yourself with the current electrical codes in your area and ensure that your electrical system meets these requirements. This may involve consulting with a qualified electrician or electrical inspector. After that is increased demand. Evaluate your electrical needs and determine if your current system can handle the load. Consider the number and type of appliances you use, as well as any plans for future additions or renovations. Next is the consideration of grandfathering. Understand the limitations of grandfathering and do not rely on it as a substitute for safety. Even if your system is grandfathered, it is still your responsibility to ensure that it is safe and functioning properly. After that is planning. Develop a comprehensive plan for upgrading your electrical system. This should include a detailed assessment of your current system, a list of recommended upgrades, and a timeline for completion. Then is budget. Determine your budget for the upgrades and explore financing options if necessary. Electrical upgrades can be a significant investment, but they are essential for safety and can increase the value of your home. After that is choosing a qualified electrician. Select a licensed and experienced electrician to perform the upgrades. Check their credentials, references, and insurance coverage. Next is permitting. Obtain the necessary permits for the upgrades from your local AHJ. This will ensure that the work is done to code and that it is inspected for safety. The next consideration is inspection. Schedule an inspection of the completed work by the AHJ. This is to verify that the upgrades meet code requirements and that they are safe. Finally, maintenance. Maintain your electrical system to ensure its continued safety and reliability. This includes regular inspections, testing of safety devices, and prompt repairs of any issues. By following these steps, homeowners can ensure that their electrical systems are safe, code compliant, and capable of meeting their electrical needs. Utilities and AHJ play a vital role in enforcing these standards and protecting the public from electrical hazards. Let's delve into specific scenarios. Imagine a home with knob and tube wiring where the insulation has become brittle and cracked over time. This creates a significant risk of arcing and electrical fires, especially if the wiring is in contact with flammable materials. Upgrading to modern wiring methods would eliminate this hazard and improve the overall safety of the home. Consider a home with a 60 amp service panel that is struggling to handle the demands of modern appliances. The homeowner frequently experiences trip breakers and flickering lights, indicating that the system is overloaded. Upgrading to a 200 amp service panel would provide ample capacity for current and future needs, preventing overloads and ensuring reliable power. Or consider a bathroom with outdated receptacles that are not GFCI protected. This poses a significant risk of electrical shock, especially in wet environments. Replacing the receptacles with GFCI-protected outlets would significantly reduce this risk and comply with current code requirements. In each of these scenarios, the utility and AHJ would likely mandate service upgrades to address the safety concerns and ensure code compliance. Homeowners who are proactive in addressing these issues can avoid potential hazards and maintain a safe electrical environment. It is important to remember that electrical systems are complex and potentially dangerous. Only qualified electricians should perform electrical work. Attempting to perform electrical work without the proper training and experience can result in serious injury or death. Homeowners should also be aware of the signs of electrical problems such as flickering lights, trip breakers, and burning smells. If you notice any of these signs, contact the qualified electrician immediately. Furthermore, regular electrical inspections can help identify potential problems before they become serious hazards. Schedule an electrical inspection at least every 3 to 5 years, or more frequently if you have an older home or suspect any problems. By taking these precautions, homeowners can protect themselves and their families from electrical hazards and ensure that their homes are safe and code compliant. This proactive approach not only enhances safety but also contributes to the overall value and longevity of the property. Staying informed about electrical safety and maintenance is a continuous process. As technology evolves and new safety standards are introduced, it is crucial to remain updated on best practices and regulations. Resources such as the National Electrical Code, publications from reputable electrical organizations, and consultations with licensed electricians can provide valuable insights and guidance. In addition to safety and code compliance, consider the energy efficiency of your electrical system. Upgrading to energy-efficient lighting, appliances, and wiring can save money on your electricity bills and reduce your environmental impact. Consider installing LED lighting, which uses significantly less energy than traditional incandescent bulbs. Look for appliances with the Energy Star label, which indicates that they meet certain energy efficiency standards. Use smart power strips to reduce standby power consumption from electronics. By incorporating energy efficiency measures into your electrical upgrades, you can create a more sustainable and cost-effective home. This not only benefits the environment but also adds long-term value to your property. Ultimately, the decision to upgrade an electrical system involves a careful assessment of safety, code compliance, electrical needs, and budget. By working with qualified professionals and prioritizing safety, homeowners can ensure that their electrical systems are safe, reliable, and capable of meeting their needs for years to come. The involvement of utilities and AHJ is crucial in ensuring that these upgrades are performed to the highest standards and that the public is protected from electrical hazards. The ongoing maintenance and inspection of electrical systems are equally important in preventing potential problems and maintaining a safe electrical environment. In conclusion, a comprehensive approach to electrical safety, code compliance, and energy efficiency is essential for creating a safe, sustainable, and valuable home. By understanding the roles of utilities, AHJs, and qualified electricians, homeowners can make informed decisions and take proactive steps to protect themselves and their families from electrical hazards. Remember that electrical safety is not a one-time event, but an ongoing commitment to maintaining a safe and reliable electrical environment.